Okay, hello everyone, and welcome to the discussion of part of the new assignment on trig functions. I hope you did well with it, and let me remind you that the way to progress in mathematics is through struggle. So if you struggle, that is good. It means you will actually, this is the way you will learn mathematics best. And it's exactly the right process. It is sometimes stressful or can cause anxiety, but in the end, the struggle is what is going to help you to be successful in the end. Okay, let's go to question 1. We won't be discussing all of the questions, but let me just say here that you will want to add sort of your baseline around which this function oscillates, and you can see the amplitude here is 3. Okay, so the value of p is equal to 3. Okay, because that is the amplitude here. Okay, and notice that the only difficulty about this question is sometimes, and this happens in IB questions, they deliberately choose letters to possibly confuse students. You have to translate this to, well, the normal way we look at things is a cos, then b x minus c plus d, right? With this here like that. Okay, and so you just need to be a little bit careful here. For the value of q, okay, you will want to apply the little formula, the period over 2 pi, not to be confused with this p, okay, is equal to b. That's the formula normally, but of course in this case we have the value of the period is, let's write that down here, p equals pi halves. I know this because you're looking for a place that repeats itself. For example, these 2 points here, how far they're apart. We can see they're pi halves apart. Okay, and therefore the value of this equation becomes pi halves equals 2 pi over q. And from this, if you manipulate, you get q equals to 4. Alright, so in question 2 I've copied out this question, the question here, this expression, and I'm looking for places of things that I can replace. So clearly I don't want any cos x, let alone cos square x, and I can replace cos square x with the Pythagorean identity. So this becomes like this, and if I expand, I will now be getting negative 2 sine square x plus sine x plus 2. I've rearranged it already a little bit, okay, because now in question B this becomes a quadratic equation. 2 cos square x plus sine x, this is the question, equals to 2. Since this here is the same as in question A, I can replace it with negative 2 sine square x plus sine x plus 2 equals to 2. Okay, this was a plus 2, and now if I subtract 2 on both sides, I get this expression here. And then I can factorize sine x and have a product of 2 things which equal to 0. Therefore I can say either sine x equals to 0, this bit, or this part becomes 0. So minus 2 sine x plus 1 equals to 0. And I will write an or here in between. Or. Okay, so let's continue solving here. If sine x equals to 0, what matters now is, of course, the range. You should have highlighted this in your question. And so, using the unit circle here, I will get x equals 0 or pi. And if you continue solving this equation, you get sine x equals to a half. And from this, using the unit circle, you should, or special triangles, or whatever method, you get pi over 6 and 5 pi over 6. Useful also to do a little sine curve here for yourselves to confirm all this. Okay. If I'm looking at the values where sine x equals to a half, then I can see I've got a value here and here between 0 and pi. So I'm looking for these two places, and they fit pi over 6 and 5 pi over 6. On to question 3. Note here that we're looking at this domain, that we're looking at degrees. This will be relevant towards the end of the question. When you have an equation without any constant terms and a mixture of sine and cos, often you will use the idea that tan x is sine x over cos x. And that's what we can do here by dividing by cos square x on both sides. So I get 3 sine square x over cos square x, and cos square x divided by cos square x is 1. So this becomes 3 tan square x equals to 1. Therefore tan square x equals to a third, and tan x equals to 1 over the square root of 3. I could put a plus minus here. Okay, let's add that just for completeness. But if I look at this range here, I know that I don't have any negative answers anyway. Okay, now I recognize this fraction as being part of the special triangles. Indeed, it's part of this equilateral triangle with a side length of 2, where I see half of it here. This is 2, this is 1 half of 2, and then if I calculate this height using Pythagoras, I get square root of 3. So if I focus on this angle here, which is 30 degrees, that one down here is 60 degrees. Okay, then I have tan defined as opposite over adjacent. So the opposite of 30 degrees is 1, the adjacent is square root of 3. That corresponds exactly to this, and so I know that one of my solutions is 30 degrees. But now I have to look at all of this. I'm looking for solutions between 0 and 180 degrees. So in order to find the second solution, a tan curve is really useful. Being very familiar with sine, cos and tan and their curves is really useful in this topic. So the tan curve is like this. At this point here you have pi halves, and the period of tan is pi, so it repeats itself here. Okay, I can see that, well, 1 over square root of 3 is some value here less than 1. And if I move over, I have my first solution here at 30 degrees. That means this distance here must be 30 degrees. Okay, now I can see there's no other solution. But actually what I said earlier about plus minus being irrelevant now appears to be not correct. It is relevant because within 0 up to 180 degrees, I actually have another solution for the negative value, negative 1 over square root of 3. I can see I have another one here, right there. Okay, now if this is 30 degrees, by symmetry, this distance here will be 30 degrees too. So I will have 180 degrees minus 30 degrees will give my other solution, or x equals 150 degrees. So actually, this plus minus here was very relevant. Okay, and on to question 5. I have skipped question 4. You can find the mark scheme on Moodle. So when it says here, find the x-coordinate of A being the intersects with the x-axis, what I'm actually asking for is the x-intercepts. In other words, I'm asking for the solutions of this equation where sine x plus pi over 9 equals to 0. In order to solve for this, well, I can do it algebraically at first. I can do the inverse sine of on both sides, and then I would get x over x plus pi over 9 equals to, well, the inverse sine of 0 is 0 plus all other solutions, so k pi, we've discussed this in class a little bit, or plus minus here, okay? So if I solve for x, whoa, something's happening with the way it records things here. Plus minus k pi, don't know what's going on here. And so x equals to k pi, come on, minus pi over 9. Okay, so if I solve for x, I get this. There's a pi over 9 here. I don't need to worry about the plus minus because my range is between 0 and pi, and I'm only going to be looking at positive values of k. So if k is 1 now, I can see clearly that x will be 8 pi over 9. I'm sorry, I'm going to have to stop here because my computer's not recording this properly anymore. So I'll see if I have to split it up into another video, or if you don't, I'll just have to refer you to the mark scheme, I'm afraid. Okay, so I'm having another go at this here, and what we've done so far is we got to this equation by solving algebraically, and I said if k is 1, then we get the solution 8 pi over 9. If k were 2, then I'd get 2 pi minus pi over 9, but that would be too big because my values can only be between 0 and pi. Another way of doing this question is to look at the fact that here we have a horizontal shift to the left as a transformation. So essentially I have a sine curve here that is slightly moved to the left. This would be to negative pi over 9 then. Okay, so instead of stopping at 2 pi, which would be here, I'm also slightly to the left. Okay, and here also, normally it'd be at pi, but in this case I'm at pi minus pi over 9. Now pi minus pi over 9 is the same as 8 pi over 9, which is what I had found algebraically. Okay, let's move on to question B. Right, so we are solving this equation here. If I attempt to do that algebraically, I need to do the inverse sine on both sides. I get x plus pi over 9. And then on this side, I have the inverse sine of negative a half. So if I'm looking at the standard sine curve, I'm looking here at minus a half. What values correspond to that? Okay. Now, if it was plus a half, I'd have the first solution at pi over 6. So by symmetry, moving on from here, I must be at pi over 6 past this number. So this is pi plus pi over 6. So that would be 7 pi over 6. So my first solution is at 7 pi over 6. And if I solve for x, I get x equals 19 pi over 18. I'll let you work this out on your own if you need to. Then my second solution will be pi over 6 just before 2 pi. So that's 11 pi over 6. So another one is x plus pi over 9 is this time 11 pi over 6. Oops, 11 pi over 6. That's this solution here. And if I solve this equation, I am getting x equals 31 pi over 18. Okay, and finally we'll discuss question 9. So it's a Ferris wheel with a diameter of 100. So really, if I think of a coordinate system actually through here, or through here, let's say, if that's my y-axis, in any case, this will be 100 meters up in the air. Okay, from this, if this is my origin here. Right, and it takes 20 minutes to go all the way around. Therefore, in 10 minutes, I go half the way. Therefore, obviously, the height in 10 minutes will be 100 meters. I'll be at the peak. And in 15 minutes, I will have gone well, it's 5 minutes to here, then another 5 minutes, then another 5 minutes. So in 15 minutes, I will be back down at 50 meters halfway through. So on to the next part of the question, question B. We have to show that h of 8 equals to 90.5 meters. Now, that's after 8 minutes. We don't know what happened after 8 minutes. I know that 10 minutes, the Ferris wheel will be up here. Okay, so it's going to be sometimes before. And by symmetry, I could look at, well, it's 2 minutes before, so 2 minutes after the start, I'm at 9.5 meters. And I know that I must be 9.5 meters before 100 because of the symmetry as we know it from the unit circle. So actually, it must be the same. It must be the case that 100 minus h of 2, okay, is 90.5. And since h of 2 is 9.5, that is 90.5, and we have just shown what we needed to show. And similarly for h of 21, well, we make a full turn after 20 minutes. So it's like finding what's after 1 minute. In fact, h of 21 must be the same as h of 1. After 1 minute, it's the same as going all around in 20 minutes and another minute to make 21. So that is quite simple. We just look it up in the table and we know that it's going to be 2.4 meters. Okay. And so if we go with the last two bits of the questions, let's first look at a graph. Well, I know that the Ferris wheel after 10 minutes peaks here at 10. Okay, somewhere here. And it starts off, of course, with height 0. And then after 20 minutes, it reaches the bottom again. And so I'm going to get a trigonometric curve, since it's a periodic process, like this, okay? Right, and you can see the biggest change here in height is at after 5 minutes, and 15 minutes is the biggest loss. Now let's look at how we can get the blue curve by transformations. Here in green, I've drawn a typical cosine curve. However, the amplitude of that cosine curve in green is 50, so I'm looking at 50 cos x, except of course also the period is different. Okay, I'll have to think about that in a moment. Okay, but I can tell already one thing, that this blue curve is in fact the result of the green curve being reflected in the x-axis and then moved up by 50. Okay, so if I look at this here, already I can say, well, there's a vertical shift of 50, and also the amplitude is 50, except I've shifted the curve, I have reflected the curve in the x-axis to make it go the other way around. Okay, so I have a -1 here, so it's a -1 and also a 50 at the same time. Okay, and now I can calculate the period, or that value of b. I used the standard formula, except I've made it the wrong way around. It's b is 2 pi over p. Okay, I need the period. Well, the period clearly is 20 minutes. Okay, 20 minutes. And so now I can insert that into this formula here. Okay, and this simplifies to pi over 10. Right, so basically I'm getting the function h of t equals -50 cos, and then pi over 10 t. This corresponds to a horizontal stretch, and then 50 shifted up vertically. Okay, and what I would do is I would take my graphical calculator and actually plot this to see if you are getting this blue curve for a check. Okay, that was it. I hope this helped. And good luck for the rest. You should go through the rest of your assignment very carefully with the mark scheme that is available to you on Moodle.